This is a telescope. This is a box. This is the Irish weather. When the rain hits, this box needs to automatically close. I need to turn this box into an automated observatory, one that protects my smart telescope from the elements. I started to do astrophotography from my back garden. That means clouds rolling fast, rain doesn't give warnings, and I can't sit outside all night watching the forecast. So if I want to protect the telescope, the observatory needs to react on its own, and this is version 1 of that system. Most of this project is in plastic, so it starts on the printer. These parts form the body of the rain sensor, the funnel, the bucket and the enclosure for the electronics. Once these are printed, everything else builds on top of that. Not everything went to plan during the printing process. So now that we have all our 3D printed parts, we now need to assemble it. Brass heat set inserts give the plastic proper threads so everything can be assembled securely. The bucket pivots on a simple filament axle. These adjustment screws control how much water the bucket holds before it tips. A light wax coating helps water flow clearly into the bucket instead of sticking to the funnel. The mesh keeps debris out while still letting the rain through. With the mechanical side now done, it's time to give this thing a brain. Before anything goes outside, I want to make sure the electronics actually work. At this stage, everything is connected temporarily using DuPont wires. This makes it easy to test, adjust and fix things before anything gets soldered permanently. The sensor itself is very simple. It outputs a number based on how close the magnet is. I'm going to upload some test code to our D1 Mini and test it out. Right now the number is very low, which tells me there's something up. As I move things into position, the number jumps right up. Once the readings are stable, I know the sensor, the wiring and the code are all talking to each other. And when we move the magnet in front of the sensor, we see a spike, and that is exactly what I want to see. Now that everything's proven, the temporary wiring can be replaced with permanent connections, and we can upload our final production code. Inside the house, a Raspberry Pi listens for messages from the sensor, so we need to get that set up. Once it's powered on, the Pi runs a small script that listens for messages from the rain sensor. When the sensor detects rain, it sends a message over Wi-Fi. And when the message appears, I know the system is working end to end. With everything tested, the sensor can now be sealed into its final housing. Bench tests are useful, but this only matters if it works outside. The sensor is mounted level, sealed and positioned where it can do its job properly. In the next episode, we take the observatory completely off-grid using solar power.